You've probably seen this happen. You show a large language model just a few examples of some new task, and bam, it instantly gets what you want. It feels like pure magic, right? Like it's learning a new skill in a split second. But there's no training going on, no weight updates, or at least that's what we thought. Today, we're going to pull back the curtain on one of AI's most incredible tricks.
So let's just get right to it. How is this even possible? For decades, we've known machine learning as the slow, deliberate process of training and tweaking and updating a model's weights. But this thing, it's called in-context learning, or ICL. It just seems to throw all the rules out the window. A fully trained model can suddenly nail a new task it has never, ever seen before, just based on a couple of examples in a prompt. How does that actually work?
So here's a super simple example. Imagine you give the model a few pairs, right? Like sad to happy, hot to cold. Then you give it up to what? And you guessed it, it spits back down. It learned the opposites game on the fly. And this isn't just the model remembering something. No, the latest research is telling us this is true learning happening in real time. The big mystery is where and how. Okay, to solve this mystery, we've got to pop the hood. We need to look inside the fundamental building block of pretty much all modern LLMs, the transformer block. And some really groundbreaking new research from a team at Google gives us this powerful new theory, and it all boils down to how two key parts work together.
Think of these two as a dynamic duo. First, you've got the self-attention layer. You can call it the context reader. Its job is to scan your entire prompt, all the examples, the final question, everything, and figure out how all the pieces relate to each other. Then you have the MLP, the multi-layer perceptron. That's the task processor. It takes all that rich info from the attention layer and does the really heavy computational lifting to come up with the final answer. And the secret to in-context learning? It's hidden in the handshake between these two.
So the researchers, they give this structure a name. They call it a contextual block. And it's a really simple but powerful concept. You've got one layer that reads the context. That's our attention layer. And it's stacked right on top of a neural network that processes it. That's the MLP. This block, this is the crime scene. This is where the magic happens. And the paper's main theorem tells us exactly how it goes down. And this right here, this brings us to the core of the whole discovery. The researchers propose that, yeah, there is a weight update happening, but it is not at all what you think. It's an implicit, totally temporary update that happens in a flash for every single prompt you write. So the huge insight here is that the model isn't just, reading the examples you provide and using them as a reference. No, it's doing something way more profound. It is actively, even if it's implicitly, reconfiguring its own internal wiring based on the context you just gave it. I mean, think